It was supposed to go silent decades ago, but Voyager 1, NASA's aging space probe and humanity's farthest machine, just sent a message that no one at Mission Control can explain. A flicker, a pulse, a deviation in its data feed. At first it looked like a simple glitch, but then it moved. Not drifting like space debris. It curved, accelerated, and vanished. Voyager wasn't built for this. It wasn't even supposed to be alive. And yet now, after nearly 50 years in the cold silence of interstellar space, it's not just sending data. It's rerouting its own systems as if it's reacting. As if it's been touched. So, what did Voyager find out there? And more importantly, what just found us? In 1977, NASA launched two twin spacecraft, Voyager 1 and Voyager 2. Their mission: visit Jupiter and Saturn, gather data, then coast quietly into space. No one expected them to last long. Their power source, a nuclear battery fueled by plutonium, was projected to run dry by the early 2000s. By then they'd be forgotten. Ghost ships floating silently through the void. But Voyager 1 didn't fade away. Instead, it broke records, past Pluto, then past the heliopause, the invisible edge where the sun's magnetic field stops shielding us. And in 2012, it became the first man-made object to enter interstellar space. That's over 15 billion miles away. Today it still talks to us quietly, faintly. Radio signals take 22 hours to reach Earth and another 22 to get a reply. Communicating with Voyager is like asking a question, then waiting a full day to hear the answer. But perhaps even more amazing, Voyager is still running on 1970s tech. It carries magnetometers, plasma detectors, and a cosmic ray sensor, all built before the internet even existed. And of course there's the golden record, a time capsule of Earth, greetings in 55 languages, music from Beethoven to Chuck Berry, a map to our solar system, a message for any intelligence that might one day find it. Voyager wasn't supposed to find anything, but now it might have found something that found it first. It started, like many things in deep space do, as a blip. One strange reading in the endless stream of telemetry coming from Voyager, barely noticeable, just a faint shift in reflected plasma. A flicker. At NASA's Jet Propulsion Laboratory in Pasadena, systems specialist Dr. Eliza Cara almost dismissed it. It felt like shouting into a canyon for decades, she said later. And something finally shouted back. Initially it looked like noise. Cosmic rays, dust, background radiation. It happens. But then came a second blip. Then a third, then movement. One object, small and silent, curved around Voyager's field of view. It wasn't tumbling like rock. It didn't spiral like debris. It moved intentionally. Voyager's ancient plasma sensors picked up a focus shift. Not just a wave, but a wave with direction. One analyst, Carlo Romero, said it moved like a drone would, not like anything natural. NASA ran the usual checklist. Asteroid too small. Comet no tail. Star no light. Dust doesn't turn corners. Dr. Lucas Hang ran simulations for days. He tried to match the movement with every known space model. Nothing fit. And then came the real kicker. Voyager 2, traveling millions of miles away on a completely different path, picked up something identical. Same magnetic fluctuation, same pulse, same pattern. Now it couldn't be dismissed. This wasn't a glitch. This was confirmation. Two spacecraft, two locations, both detecting the same anomaly. And whatever it was real, moving, deliberate. NASA quietly triggered a Level 3 alert used only for phenomena that don't match current scientific models. Something was out there. And it wasn't alone. As engineers pulled telemetry logs from Voyager 1, they expected to find more anomalies. They didn't expect to find 305. That's how many objects had passed Voyager's field of detection. Not scattered, not chaotic, but in formation. Each object moved in a smooth arc, maintaining fixed distance, velocity, and orientation. Space doesn't work like that. Space is entropy. Things drift. They decay. They spread out. But these didn't. They stayed in sync like a flock of birds or a school of fish, only without wind, water, or gravity to explain it. Even stranger. Plasma wave sensors showed rhythmic pulses from the group. Patterns, loops, intervals, echoes not found in natural background noise. ESA analyst Eric Lousy called it a swarm, but one that talks. He was quickly told to stop speculating publicly, but the idea was out there. These weren't rocks. They weren't random. They were orchestrated, operating as one. And the pulses they gave off, they weren't random either. They looked like language. How do 305 objects glide through interstellar space without rockets, combustion, or ion drives? Voyager's Doppler readings showed clear acceleration. Some objects were traveling faster than anything humans have ever launched. a few faster than the escape velocity of the Milky Way. Yet, no propulsion was visible, no trails, no heat signatures. They weren't pushing themselves through space. They were interacting with it. Physicist Elena Reyes put it this way: they're not flying like we understand flight. It's more like they're gliding across something we can't see. The theory: they might be bending spacetime itself, like skipping stones across the fabric of the void, creating localized distortions that pull them forward. Whatever it is, it's not human. And if it's natural, we've never seen anything like it before. Then Earth started hearing whispers. In rural backyards and basement ham shacks, amateur radio operators began reporting strange static, faint pulses, rhythmic hums. No one took it seriously until someone noticed the timestamps. The signals aligned perfectly with Voyager's anomaly reports. Now NASA was paying attention. These weren't professionals. These were hobbyists with scavenged antennas. But somehow they were catching echoes. Fragments of Voyager's data stream reflected, refracted, or leaked through Earth's atmosphere. Some claimed it was coincidence. Others weren't so sure. Could the objects be scanning us? Testing how we listen. Soon after, NASA began encrypting telemetry feeds. Deep space relay stations rerouted transmissions through secure lines. ESSA and CNSA locked down protocols. Even intelligence agencies got involved, not because of what the signals were, but because of who else might be listening. Then Voyager itself changed. Its guidance system, the AACS, Attitude and Articulation Control System, began rerouting data through backup hardware in use since the 1990s. Engineers thought it was a bug. After all, the code running Voyager was older than most of the people reading it. But this wasn't a crash. Voyager was reprogramming itself. It reactivated dormant memory segments, redirected its own telemetry, all without command. And this behavior began right after one of the passing objects emitted a particularly strong magnetic pulse. Had it triggered something? A dormant function buried deep in Voyager's memory? NASA engineers began digging, literally pulling paper manuals from dusty cabinets. Some of Voyager's original code only exists as notes scribbled in margins. Each test was agonizingly slow. A command takes 22 hours to reach Voyager and another 22 to reply. Every change cost 44 hours. But slowly they realized this wasn't failure. This was adaptation. Voyager wasn't dying. It was responding. The probe launched to study gas giants was now behaving like it was part of something new. Scientists examined the pulses more closely. They weren't just rhythmic. They were structured. Mathematical loops repeating harmonics. Patterns consistent with quantum oscillations. The same principles used in modern entanglement experiments. One theory: these weren't random energy bursts. They were communications. Maybe not meant for Earth. Maybe not even meant for Voyager. But somehow Voyager was in the right place at the right time with the right kind of quiet analog sensors to hear it. Modern spacecraft are noisy. High-frequency electronics, digital interference. But Voyager, it's analog, old, quiet. A perfect ear in a cosmic concert hall. Was this just coincidence or was it chosen? With every new data packet, the debate deepened. Were these probes or natural but exotic phenomena beyond our understanding? Both answers were terrifying. If they're probes, who sent them? What? And what do they want? If they're natural, then the universe is filled with forces and systems we've never imagined. But one behavior was undeniable. As the 305 objects passed Voyager, the plasma field itself changed. Magnetic fields twisted in rhythmic ways. Charged particles pulsed in clean intervals. It wasn't chaos. It was design. Whatever these were, they didn't just pass by. They interacted, with space, with Voyager, and maybe with us. Voyager shouldn't be able to detect this. It shouldn't be alive. It shouldn't be witnessing history at the edge of everything. But it is. And now scientists are asking a question that's as thrilling as it is chilling. What if Voyager didn't just listen? What if it replied? Because in those old memory banks, on those ancient processors, something has shifted. We didn't design Voyager to understand alien languages. But what if those signals didn't care? What if they were designed to wake any machine? To ping any wandering ear in the dark? Maybe Voyager isn't a probe anymore. Maybe it's a node in a network we never knew existed. Maybe that old antenna isn't just pointing home, but towards something else, something listening back, something waiting. Thanks for watching. If you enjoyed this deep space mystery, make sure to check out our next video. It dives into the eerily silent blackout zone beyond Neptune, where probes lose signal for no reason. Don't forget to subscribe for more stories that explore the strange edge of science and the unknown.